Good day everyone, my name is Lim Wei Sen, and today I would like to present my final year's project titled the MANET Testbed, and this project is supervised by the Dr. Shankar. Firstly, I would like to introduce about what it means by MANET. MANET stands for the Mobile Ad-Hoc Network, and it has three characteristics, which is the mobility, dynamic, and no need for the centralized infrastructure such as router or switch. From this figure, we can see that there are three Raspberry Pi nodes, and each are responsible for the communications, and there are no routers or switches in between them for doing the switching of routing information. Besides, each node can join or leave the testbed at any times. Moving on next is the problem statement. As we know, there are two types of ways to simulate the MANET environment. First is through the online simulators, and another one is through the testbed. However, relying only on the simulators will have some limitations, which do not provide the realistic and real-time results, such as the path loss and also radio interference are not easily to be simulated. Besides, there are also problems like MANET environments are currently not available in USM, hence I decided to develop an own MANET testbed. Next is the system objective. The first objective will be to establish a MANET testbed where each node can communicating with each another. Secondly, to enable the dynamic problem be facilitated with quick deployment of different routing protocols using the same testbed as well as same dashboard. Secondly, to provide a centralized interface for allowing users to monitor the status of MANET nodes and also the information of each node. Hence, a proposed solution to achieve the objective and also to solve the problem is established, where a MANET testbed, whether each Raspberry Pi node is able to communicating with each another using the different types of routing protocols. Secondly, there are also a user-friendly dashboard for users to sort between the different types of routing protocols and also view the information of nodes. For the system module diagram, there are three modules. The first one is a network infrastructure module, secondly, network system module, and also the last is the web application module. For the network infrastructure module, it serves as the basic or foundation for my whole entire FYP project. The Raspberry Pi is chosen to be the MANET nodes, and static IP address is configured in each node by turning off the Wi-Fi mode and switch on the Ad-Hoc mode. Besides that, the routing protocols such as ORSI and Batman Advanced is configured in each Raspberry Pi nodes. And this figure shows the MANET testbed topology, also the placements of Raspberry Pi nodes in the NAV6 USM. Moving on to the second module, which is the network system module, including the protocol service creation, where the Linux daemon service is created, which continuously running at the background to query the protocol which protocol is currently active, which will be useful for doing the switching protocols later on. And secondly is the monitoring tools, where the promoters is used to extract the metrics or information such as the CPU usage and total uptime from each Raspberry Pi nodes, and then export to the Grafana as the data source to visualize those metrics on beautiful dashboard. For example, this is the interface for the promoter server, which shows the number of nodes that are currently connected to it. And this is the Grafana dashboard, which using the data source export from the promoter server and turning on into chart and graph, which clearly shown to the users. The last module will be the web application module, including the interface for users to switch to dynamic routing protocols flexibly, and also user interface for users to view the number of MANET nodes connecting to the testbed. To explain the web application module in details, for example, these two Raspberry Pi nodes are now communicating using the ORSR protocols, and then the current protocol will then be shown on the dashboard. And After the user clicking on the swapping button, now the two Raspberry Pi nodes will communicating using the another protocols, and the current protocol using it right now will also be shown on the dashboard. Hence, for the system architecture, each Raspberry Pi are communicating using different types of routing protocols, and also those information and metrics will then be exported to the Prometheus server. After the Prometheus server collects this information, it will export to the Grafana as the data source for visualize it in a beautiful dashboard. And then for the switching of routing protocols, Grafana will call the backend service of each Raspberry Pi to do the switching between the Linux daemon service file through the Python Flask as the API server. For the impact and benefits, it includes that users can view the information of MANET Testbed from the dashboard panels, such as the CPU, memory, and also the number of nodes. Secondly, it provides an existing MANET testbed for users to freely modify things, like changing and iterating the routing protocols. Thirdly, the MANET testbed can be transferred to the real-world scenario easily, which reduces the cost and also error recovery time. For the entrepreneurship opportunity, it has managed MANET service, which offer the management of MANET service from initial network configuration to ongoing monitoring for organizations or individuals who are struggling to set up the MANET for their specific needs. Besides, it has big competitive advantage compared to other MANET testbed, such as there are quick deployment of different MANET protocols using the same testbed, which allowing users to monitor the status and also switching the routing protocol within the same dashboard. Besides, it provides the MANET as the network as a service, or like the software as a service and pay per use model for organizations or individuals who need on-demand access. It will be a cost-effective solution for short-term use case and also easily to be provisioned and configuration by those organizations. Besides, according to the market needs, there are three types of market that we can aim for. The first one is the disaster management, which provides a solution for emergency response teams that need a reliable communication network during a large-scale event or natural disaster. Secondly, we can also aim for the IoT and smart city, where it provides IoT solutions where devices can communicating in decentralized ways, and including applications in smart cities such as the traffic management system, environmental monitoring, and public safety networks. Thirdly is the healthcare and emergency response, where MANET enables mobile health units that can operate in remote areas, which provides connectivity for medical teams and facilitate the telemedicine applications. For future improvement, there are three plans, including configure more types of routing protocol so that different types of protocols can be tested. The secondly is increase the scalability by adding a new or more MANET nodes. Thirdly is creating a documentation on teaching that users how to configure the MANET nodes and utilize the dashboard. Next, we will moving on to the system demonstration. So now I would like to continue with the system demonstration of my FYP, which is the MANET testbed. Now I have remotely logged in to the Raspberry Pi and open up the local dashboard. So this is the login page of my MANET testbed dashboard, and I am now trying to log in as the system admin. So after successfully logging in as the system admin, you can see that as the admin, we have the permission to adding the new connection or new Raspberry Pi to the dashboard, or adding new API server as the data source for those Raspberry Pi. So in the dashboard, we can see that we can create and manage the dashboard we want to visualize our Raspberry Pi. So for example, for this dashboard, we can view the number of nodes that are connecting to the MANET testbed. So currently we have two Raspberry Pi that are communicating with each another at the MANET testbed, and each of it are separated with the different IP address. The first one is 192.168.0.30 and another one is .40. And here it also shows some simple information of each Raspberry Pi, including the total uptimes, the total memory number of CPU cores, the percentage of CPU use, memory use, and so on. And below that, there are also graph and chart that shows the information or data metrics in details. And as the system admin, we can also easily change the interface of the dashboard. And also as well as saving it. Moving on to the next dashboard, it shows the more details for each Raspberry Pi nodes. For example, including the protocols or routing protocols that they are using it right now. For example, currently the first node and the second nodes are communicating using the OLSR protocols. And there are also buttons for switching the routing protocols and also reboot the Raspberry Pi. Below that, it also shows the number of CPU cores, the time span, and also the CPU loads, as well as the memory, network load, disk space use, and also disk utilization. Similar with another dashboard, system admin can also easily change the user interface of the Grafana dashboard. So for the swapping or switching routing protocols, when the system admin click on the swapping button, the Grafana dashboard will ask the backend of the Raspberry Pi to switch between the daemon service of the routing protocols by turning one of the routing protocols into inactive and another one into the active. So as a result, the OLSR protocol will be changed to the payment protocols. Same goes to the second node of the Raspberry Pi. When we click in on the switching protocols button, it will also change from one protocol into another protocol. That's all for the functionality of the system admin. So now I will log in out and try to log in as the normal users, which do not have the functionality of adding new nodes or changing the interface of the Grafana dashboard. So after we successfully log in as the normal users, we can also view the dashboard that we want to visualize the data metrics of the Raspberry Pi nodes. So for the normal users, we are not allowed to adding new nodes or changing the interface, but we can also perform the functionality of switching of the routing protocols for both of the Raspberry Pi nodes. Hence, that's all for the system demonstration. Hence, that's all for my entire FYP demonstration. Thank you so much for watching.